Hello everyone, welcome to Code Compass. Today we are going to solve product of array except self from Leetcode Top Interview 150 list. So let's go to the problem statement. It says given an integer array numbers, return an array answer such that answer of I is equal to the product of all the elements of numbers except numbers of I. So basically they have given us an array 1 2 3 4, and in the output they are also expecting an array, and each element is supposed to contain the product of all other element in the array except that particular value. Okay, so for example over here except 1, the value of product of all other elements is 2 into 3 into 4, so it becomes 24. For this particular position it becomes 4 into 3 into 1, so it is 12. For this particular position it is 4 into 2 into 1, so this has 8, and for the last value it will be 3 into 2 into 1, which is 6. But their restriction is that we must write an algorithm that runs in linear time and without using the division operation. So we are not allowed to use the division operation, and we must write an algorithm which runs in linear time. And if you look at the follow-up of this problem, it says can you solve the problem in order of one extra space. Basically they don't want you to use any extra space, and they have mentioned the output array does not count as extra space for the space complexity analysis. So in this solution we are going to be discussing this particular answer where we will be calculating the required result in linear time, and without utilizing any extra space we will only utilize the result array which we are allowed to use. So let's go to the intuition for this problem and try to understand how to approach this. Okay, so now let's try to see let's try to understand the intuition behind this problem, and we are going to be discussing the solution which is implemented in linear order of n time, which is linear time, and which does not require any additional space. And remember, the output array itself does not count as any additional space. So let's look at the example again. It is 1, 2, 3 and 4, and at each position we need to put a number which represents the product of all the other elements in the array apart from that particular element. So there will be two steps to this. So first of all, let's say I initialize an output array which is initially empty, or I will call it as, let's say, result array. You could call it anything. It is initially empty, which will be of size 4, and what I do is I start traversing the input array from the right side, and I start putting the elements. I will start accumulating the product from the right side of the input array, and I will put them in the result array. So this is not the final result, this is just an intermediate step. So let's see what will happen. So I will put over here 4, then I will come to this position, so I will multiply this with the previous element. I will put 12, then when I come to 2, I multiply with 12, it becomes 24, then I will multiply 1 with 24, and I will again put 24. So right now my result array is basically holding the product of the array elements from the right side. So each index of this result array is currently denoting what is the product of all elements in the input array up to that particular index. So index number 1 in result array denotes the product of all elements in the input array from index 1 till the end of the array. So it is 2 into 3 into 4, which is 24. Similarly for second index, if you see, it will be 3 into 4, which is 12, and for the last index it is simply 4. So right now we have reached an intermediate step where I have stored the product of all elements from the right side up to each position in the result array. Now let's come to the second step, and now I will initialize one variable. It is a variable, not an array, which will be, I will call it as left product. And if you carefully think, if at any point of any index I am somehow able to determine what is the product of all elements towards the left of this element and what is the product of all elements towards the right of this element, I can figure out what should be the final answer for that particular index, because I will simply multiply those two values and update them in the result array. So now you already have the product values of all elements to the right in the result array. This intermediate values that you have, these are denoting, using this array you can very directly see what is the product of all elements to the right of any particular index. But for the left product, I will maintain a variable. As I traverse the input array from the beginning, I will initialize it with 1. So what I will do, I will traverse from the first element in the input array to n minus 1, and I will put, so at each index what do I need? I need the left product, I already have it. I need the right product. Okay, so basically I will update result of I will be left product, right, into my result array, which is already holding the product of all the elements to the right of any, basically to the right of that index. So for position I need to exclude this particular value. So I will simply pick I plus 1. So now you get whatever you need, what is the expected value in this particular cell. So listen to this again. Left product is currently holding the value of all the elements from the left multiplied to each other. And then for the right portion, you already have it stored from this pre-processing in result of I plus 1. So you get both these values, you multiply it and you update it in the result current index in the resultant array. So this is the final value which should be lying in the result. And after this is done, we will update left product for the next iteration. And that will be, I will multiply it with the current value, current array value. So now in the next step, you will again have the left product value and you will again have the right product value. You will again multiply both of them and put them in the resultant array. But we will have to do special handling for the very last value, because for that there will not be result I plus 1. So we will not be able to do this n minus 1. We will have to stop one step prior. So basically what I'm trying to say is, when you reach this particular index where value 4 is stored, which is index number 3. So for 3, you cannot do result of I plus 1, right? Because then you will go outside the bound. So we will have to do that handling, and in the end, we will simply have to put result of last basically index will simply be left product, because by that point, left product will be holding the product of all the values in the array apart from the last member of the input. So we will do this special handling and eventually our result array will be finalized. So let's try to do a dry run for this entire approach, and then things will become much more clear. And for the dry run, I will actually use input number 2 because it has 0 values as well. So things will become much more clear. Okay, so over here I have written example number 2. So this is the input. It has -1, 1, 0, -3, and expected output is 0, 0, 9, 0, 0. Okay, so let's first of all start by declaring a result array. Okay, it will have 5 elements. Now I will, going back to this logic, I will simply traverse the input array from the right and I will start putting the values in the product format from the right side. So initially it will have 3, this will have -9, -9 into 0, this will become 0, 0 into 1, it will become 0, 0. So basically everything to, which lies, for every element which lies prior to 0, 1, 2, 3 and 4, prior to second index or prior to it, it will, the product of all elements to the right is always going to be 0. Okay, now let's start seeing what happens at each particular iteration. Okay, so I will have 3 things. Okay, I have defined, and I will keep updating result array so that you clearly see what is happening at each step. Okay, so over here I will write I is equal to 0, I is equal to 1, I is equal to 2, I is equal to 3. I am writing I is equal to 4 somewhat separate because this will be special handling after the iteration is over. And let's start by defining left product. And I will keep writing how the result look like at each step. Okay. So initially we have we will be initializing left product with 1, and result prior to I is equal to 0 will be looking like 0, 0, 0, minus 9 and 3. So at I is equal to 0, what we will do, we will simply be doing a left product into result of I plus 1. Okay, so and over here I plus 1 is 0 and we will be updating this particular position. So this becomes 0, no changes over here. Okay, so for the next iteration it becomes 0, 0, 0, minus 9 and 3, and left product will be multiplied with result of I. So result, input of I. So input of 0 is minus 1, 1 into minus 1 will become minus 1. So for the next iteration now, I have left product as minus 1, and now clearly see, we are over here, left product is saying minus 1. So product of all the elements prior to this element is minus 1, and it is showing us the correct number also. But at now we will see at I is equal to 1, what is the value of result of I plus 1, result of 2. So result of 2 is again 0, and we will over here we were updating this particular value. Now we are trying to update this value. So this value will be minus 1 into 0. So it stays unchanged. Okay. So now for next iteration, this will become 0, 0, 0, minus 9, 3. So far no changes. And now we need to update left product. Left product will be left product into current value. So minus 1 into 0. That will be 0. Now at I is equal to 2, we are trying to update this particular value, right? So at minus 1, this will not be 0 because we need to multiply with the numbers of I, not result of I. So minus 1 into 1, this will be remaining minus 1 only. Now at I is equal to 2, now we are trying to update this particular block. For this, we will multiply left product, which is minus 1, with the next value, which is minus 9. So this will become in the next iteration 0, 0, minus 1 into minus 9, that will be 9. Now this is minus 9, this is 3, and now minus 1 will be multiplied by this value. We are at over here. So minus 1 into 0, this becomes 0 for the next iteration. And now we are trying to update this value in the resultant array. Okay, for that left product is 0 and result of I plus 1, which is 4. So result of 4 is 3. So 3 into 0, this becomes 0 for the next iteration. So this becomes 0, 0, 9, 0 and 3, and left product will be multiplied with this current value in the input array. So my 0 into I is equal to 3, 0 into minus 3, that will become 0. And over here, since now we have run out of the loop, for special handling case, this will be set to now we need to update this particular block, which is 3. So this will be set to the last value which we have in left product. So then eventually our result becomes 0, 0, 9, 0 and 0. And if you compare, this is exactly what was expected of us. So take a few minutes, see this dry run again, and then the approach will become much more clear to you, and then we will go to the code for this problem. Now that you understand the intuition behind this problem, let's try to put it in the code. Okay, so let me start by defining a variable size, which will be equal to the number of element in the array, and let us initialize the result array. New int size, it will be same length, and eventually we are going to return this at the very end. Okay, so now let's start with step number 1, which is filling the result array with the product of elements starting from the right. So I will first of all initialize the last element in the result with the last element in the input. Then starting from the second last element, I greater than equal to 0, I minus minus. Now my result of I will be result of I plus 1 into numbers of I. So now result array will have product of all elements starting from the right side. Then we will initialize a variable left product. It will be initialized with 1. Now we will start from the starting position and we will go to the second last position. So because for the last element we will need special handling. So over here at any particular index we need the left product and the right product, and we need to put their multiplication in result of I. So left product will be left product into right product is contained in result of I plus 1. So at this point result of I has the final expected value which is required, and we need to update left product for the next iteration. So we will multiply it with the current value, and in the end for the last value for the last element we will need special handling. So we will put left product over there, because by that time left product will be holding the product of all the elements in the array. So let's see if this one works. Great. So the base test cases are passing. Let's try to submit this. Great. So all our test cases are passing. I hope the intuition and code were both clear for this problem, and if you like the explanation, please subscribe to our channel, and we'll see you in the next one.